Welcome, students, to Saxon Algebra 1. This is Lesson 1, Addition and Subtraction of Fractions, Lines and Segments. This should be a review for pretty much everyone, back all the way into your 4th and 5th grade math, I do believe. But a quick review just to get us in the swing of things. So let's begin. Section 1A is the addition and subtraction of fractions. We know that if we want to add and subtract fractions, the only thing that we need is a common denominator. So as long as the denominator is the same, we just add and subtract the numerator across the top, just depending on whatever operation we're given. So for instance, if this were subtraction instead of addition, then we would have this as a result, because 5 plus 2 is 7, and 5 minus 2 is 3. But what if the denominators are different? For instance, if we have 1/3 plus, let's say 2/5. We can't readily add those because they represent completely different values or different parts of a whole. We need to build a relationship by breaking these fractions into the same number of parts per whole number. That relationship of a common denominator has to exist between fractions before we can combine them or subtract them from each other. Okay, so the easiest way to do that is to look at the denominator here. I didn't really mean to do that. We want to look at the denominator here and look at the denominator here and ask ourselves, are those prime numbers? Yes, they are. So if they're both prime, you don't even have to think about it. You just have to multiply each fraction by the opposite denominator. So that's going to give us 5/15 plus 6/15. Now that they have the same denominator, we can easily do the math. And that is our result. What if we have subtraction and we have 2/3 minus 1/8? In our heads, we know that 2/3 is bigger than 1/8 because it takes 8 pieces to make a whole here and only 3 pieces to make a whole number here. So these have to be bigger pieces, right? But we can't explain that relationship just by having these uncommon denominators in this problem. So we will again look at the denominators and see if we can't build a relationship by making them common. The easiest thing to do here, first of all, we see this one's prime. So let's look for a relationship with 3 in this 8. There's not one because 8 is 2 times 2 times 2. There's no 3 factors in there at all. So we're going to just go ahead and multiply like we did up here with 2 prime numbers. So we end up with 16/24 minus 3/24. Now we see that relationship. We know that these are the same size pieces, and we can easily perform the math, and we end up with 13/24. And that is the correct answer. What happens when we have whole numbers added in to the mix? We call those mixed numbers, and a mixed number is something like this right here, 13 3/5. And we know that it is 13 plus 3/5. It is not 13 times 3/5. That is a distinction that I want to draw to your attention right now, or draw your attention to right now. So let's say we have 13 3/5 plus 2 1/8. Well, right off the bat, we know this is a prime number, and we know there are no 5s factored in 8, so we're going to have to multiply. So we end up with 13 and 24/40 plus, if I can get my pen to work here, 2 and 5/40. Notice I didn't multiply the whole numbers. We don't need to multiply the whole numbers because the only thing that we need to build a relationship with is the fractions. The whole numbers already have a relationship to each other because they are complete sets, and we can always add complete whole pieces to each other or subtract whole pieces from each other without having to have a separate relationship. Fractions, on the other hand, have to be broken into the same number of pieces per set. We have to have a relationship of size or units in order to do the math. So now we can add, and we end up with 15 and 29 over 40, which cannot be reduced because 29 is a prime number. So that is our final answer. What if we need to subtract? I'm going to change colors. If we have 13 and 3/5, let's say we're going to subtract 2 and 7/8. Okay, well, first of all, we have to put this into a common denominator. And we've already done 5 and 8. We know we can go to 40. So we're going to say 13 and 24 over 40 minus 2 and 35 over 40. Oh, but we can't do that because we can subtract 2 from 13, but we can't subtract 35 from 24 and have a positive. You can't have a positive whole number with a negative fraction. It just really doesn't work that way. Now, there are a couple of different ways that you can do this. The first way is the way that most of you probably know, and that's borrowing. So we would borrow 40. We would take one whole piece from the 13 and break it into 40 pieces and add it back. So we would take this down to 12. We would add 40 pieces here, and we would bring this up to 64. Okay, that is the first way. And we would end up with 12 minus 2 would be 10. 64 minus 35 would be 29 over 40. Okay? The other way is to break these into separate parts. And that would be whole numbers and fractions by themselves. So you would actually end up saying 13 minus 2 would be 11. And then 24 minus 35 would be minus 11 over 40. Okay? So if you have 11 minus 11 whole minus 11 40ths, you're going to do the same thing. You're going to turn this into a 10, and then you're going to have 40 over 40, right? And then you're going to subtract your fraction. 40 minus 11, you're just going to bring your 10 over. 40 minus 11 is 29 over 40. It's the same answer. Same answer. You just, you didn't have to borrow here, you borrowed here. You rewrote it. So whichever one makes the most sense to you, that is what you'll do. Because technically what you're doing here is what you did here. It just might be a little bit more messy and harder to understand. It's up to you. You can do whichever one works for you. You can always check it using the other method and make sure you get the same answer. And if you do, then you're okay. All right, moving on to lines and line segments. If you need to take notes, right now, pause. I'm about to clear the page. All right, lines and line segments. So a line, we know, is a straight path with no beginning and no end. And we identify that by drawing a line with an arrow on each end. That is a mathematical line. We can name a mathematical line in a couple of different ways. We can give this some letters, these points some letters, and that's how we can name them. We put points on the line, we give the points capital letters, and then we name the line according to the points. So we could call this any line we wanted to, as long as we recognize these points. We call it AC, we call it line ABC, We could call it line CA, CBA. We could call it line AB. We could call it line B. We could call it line C. It just, usually, typically what we do is we either call, or not call, but name a line by the first and last point or by all the points. Usually there's no more than 3. There could be 4. When you get a bunch of points, it's standard to just use the first and the last, because the whole point of writing like this is to save time and to save space when doing a mathematical problem. So you want to shorten it as much as possible, so the first and last are the ones that are used when you have a lot of points. Okay, so what's the difference between a line and a line segment? Well, a line segment it's a segment. It is a part of a line. It is a definite length. Whereas a mathematical line has no beginning and no end, a segment has a definite start and a definite finish, and they begin and end in a point. So if I wanted to, let's say, call this MX, this would be called segment MX. It wouldn't be called line MX. We would call it segment. And we would identify this segment when we write by just putting a little line, no arrows, and an M and an X. We could have other points on here and that'd be fine. Segments and lines are treated the same in that if you have a whole bunch of points in between, you just pick the first and the last one to give it the name, because the whole point is brevity. Brevity means doing it the short way. So let's do some example problems now that we have taken the time to understand the difference between a line and a segment. I'm going to give you the opportunity to write that down. If you need a minute longer, you can go ahead and pause me. I'm going to clear the page. All right, example problem 1.1. Now, I'm going to take a moment and say, you should be writing down everything that I write down, especially the example problems. And if I take the time to write down words or formulas, it is vital that you write down those words and formulas, because I am not going to put a whole lot of words on here when I do these lessons. So the ones that I do take the time to write down are going to be important ones. Most of the time we're just going to be doing calculations and practice problems. So any words, any definitions, any formulas, and definitely any problems or examples, write them down in your notebook. You will need them. So let's begin. We have a fraction problem. We have 10/11 minus 5/6 plus 1/3. Now, we can see that we need a common denominator. If we look at the last two fractions, we know that we have a relationship because 6 has a factor of 3, and this is a 3. But we cannot reduce this because this is a prime number. So what we want to do instead is take the other factor of 6, which is 2, and multiply it times this fraction. And then what we end up with is 2/6, because 2 times 1 is 2 and 2 times 3 is 6. Now we have a common denominator between these two fractions. Now we just need to find a common denominator between the 6 and the 11. And because 11 is prime, we're going to have to multiply. But that's easy peasy. So all we're going to do is we are going to take 6 and multiply it times this fraction. And we get 60 over 66. And then we're going to take 11 and multiply by these two fractions and just bring down the operation. So that's 55 over 66 plus 22 over 66. And now we can perform our calculations. Now that we have a common denominator, it's going to be something over 66. 60 minus 55 leaves a remainder of 5. 5 plus 22 is 27. Now if we factor 27, we get 3 times 3 times 3. excuse me. If we factor 66, we get 2 times 3 times 11. I can see right away that I have a common set of factors here that I can take out, and we'll get rid of those. And now we're left with these factors, which are not in common, so we have to multiply them back. 3 times 3 is 9. 2 times 11 is 22. That's as far as we can go. That's as much as we can reduce, so that is our answer. Example 1.2. We have a line segment here. It's line segment ABC. It's A. This is B. And this is C. And we are told that the entire length of ABC is 10 1/4 something, some unit long. We don't know how long that is, but it's 10 1/4 long. And then we're told that AB is 4 3/7. So this is 4 3/7 right in here. So what we need to do is find the difference between this entire length and the length of segment AB. And then that will give us the length of BC, which is what we're asked to find next. So all we have to do is say 10 1/4 minus 4 3/7 is going to equal segment BC. Okay? And technically that would be the measure, and that little m represents the measure when we put it in front of a geographic identifier, I guess is the right word to say. So first of all, we have to get the same common denominator. And in this case, because 7 is prime, we know we need to multiply. So 10, and we have 7 over 28 minus 4, and we have 12 over 28. Well, we cannot subtract 12 from 7, so we're going to borrow, and that's going to leave us with 9, and if we add 28 pieces to 7, that gives us 35 over 28 minus 4 and 12 over 28. That equals 5 and 23 over 28. We cannot reduce 23. It's a prime number, so this is our final answer. Now what we can do is we could take this, we can put this length right here on our number line to illustrate that we found the answer to that length. Okay? That's all I have for problem 1, or lesson 1. If you have any questions, or you're something that you just don't understand, or I didn't make it clear enough, please feel free to message me, and I will see you in lesson 2.